right? So polynomial could have many terms. The terms are going to have x's in them, y's in them, things like that. They could be to different powers, right? That's all part of what we'll do in the next little bit. But specifically, one thing that we're going to have to do is to know how do you multiply two binomials, right? And by binomials, we mean things like x plus 2 times x plus 3. And we'll learn a technique that's, I would call algebraic, which is called FOIL. I don't think you've seen that before, have you? Have you seen FOIL? I don't know why they teach stuff at younger grades, and so you might have also seen using the algebra tiles then, have you? Okay, I'll show you and you can tell me whether you've seen them before. I mean, personally, I think the reason that they do algebra tiles is that it's specifically that you're going to have tiles. You're going to have something like you can touch on your desk that you can like put together to figure out, you know, this binomial times this binomial. But as far as I know, we don't have any of those things. All we really have are the pictures of those things. And on the SOL for Algebra 1, there's always one problem, which is using the algebra tiles, but it's a picture of them. I mean, you don't have them. I mean, you know, I'm sure some of you have heard this stuff, you know, some people are auditory learners and some people are tactile learners and all this stuff. Okay, well, the tactile learner stuff would be maybe you're helped if you got it in your hand and you could touch these tiles. If it wasn't for that, I probably wouldn't teach it, you know, but, you know, it's in there. I know it's in there. And it's not bad. And for all I know, it's going to help somebody go, oh, yeah, I get it. So that's why I'm going to go through this thing about the tiles. How do we multiply linear factors with these algebra tiles? And by linear factors, what it means is it's going to be one or two terms, right? The highest power of x is going to be a 1, right? All of these are examples. X plus 2, x minus 3, 2x minus 3, 3x, it's only one term, 4x plus 5. That's what we call a linear factor. Okay. Now, mostly what we're doing, it'll be 2 terms times 2 terms. And we're using these algebra tiles, it just can't be anything else. Right? There's nothing else we can really do with it. So we're going to learn how we can do something like x plus 3 times 2x plus 1 today just by using these tiles. And then, you know, next class we'll actually do the algebra and multiply them out. I doubt you'll use the algebra tiles after when you don't have to. I would hope you move on to knowing the algebra. So by the algebra tiles, what we mean are these things right here. Okay. The algebra, if you notice, every one of those is somewhat of a rectangle. In fact, 2 of them are squares and 2 of them are rectangles. Right? And the length of the side of the big square is x. And since it's a square, that means all the sides have x as their side length. Do you remember how you find the area of a square? Yeah, I mean, it's a length times width for a rectangle. For a square, it's just the sides squared because the length and the width are the same thing, right? So this one, if I put this in here, I need to get a bigger thickness here, maybe something like this. Right? This thing has an area of x squared, x times x, right? So that's what that tile means. If you look at both of the long rectangles, one side is considered to be 1 wide, and the other side is considered to be x wide. So what would be the area? Length times width, 1 times x, x, right? So these are both x's, right? And then what would be that square which has 1 on each side? What would be the area of that? So 1. So these are your algebra tiles. One of them's got an x squared, right? It's the big square. 2 of them are x's. They're actually the same rectangle, just one of them straight. Because we're going to, as I copy it around here, it'll be more convenient to already have it standing up or laying down. And then the little one is 1. So that's going to be our tools for doing this. Okay, so here's the next page. I've got my algebra tiles off in the top left. And I think probably the way I'm going to have to do this is just with my cursor. So I'm going to multiply x plus 3 times 2x plus 1. So notice that I've put here, right, I've used one x tile and 3 1 tiles on the left side. And on the top, I've used 2 x tiles and 1 1 tile. So that's 2x plus 1. That's this one right here. Right? This one is x plus 3. That's this factor right here. Okay. So when I multiply using the tiles, right, in order to multiply x times x, I'm going to use one of these. I'm going to use one of these x squared tiles. So I'm going to go Control C, Control V, and let me drag this thing there. Okay, and it looks like I'm going to need another one of those here. Oh, I can just go to Control V, get another one. Another one will go here. Okay, it looks like right here, underneath those blue x squared tiles, that's going to be a rectangle which is 1 on one side and x on the other. So that's like this right there. Control C, Control V. So I'm just filling this in. Need 1, Control C, Control V, 2, Control C, Control V. It might be easier if we actually had tiles, to tell you the truth, but we don't. So I need 2 more there. I need to do that one more time. Okay, what am I going to put right below this yellow 1? It's x on one side and it's 1 on that side, so it's this one right there, right? Control C, Control V. Let me grab that one. Oh, that didn't work. Let me put that one there. And now what are we going to fill in underneath to the right of all those 6 x's and below that 1x? What's going to go here? They're 1 on one side and 1 on the other, so I need 3 of those, right? So Control C, Control V. That didn't work. Try this again. So I need 1 there. And now I'm going to do Control C, Control V, and finish. So I just filled in using my algebra tiles. Now I'm going to add up the tiles that I used. Draw. I hope this works. It does. Okay, so let's see. I've got 2x squareds, right? Count them. 1, 2, that's 2x squareds. How many x's do I have? 1, 2, 3, 4, 5, 6, 7. Plus 7 x's. And how many 1's do I have? 3. Okay, that's the answer. We just multiplied x plus 3 times 2x plus 1. The answer is 2x squared plus 7x plus 3. Right. Let's try to, I'll do another one. We'll do another one, okay? All right, this time, notice what we're multiplying here, right? This is what we're multiplying, right? Here's 3x plus 2. 1, 2, 3x plus 2. Here's 2x plus 1. X, 1. Okay, now we need to use these squares to fill in here. Okay? So what am I going to fill in these areas here? It's x on one side and x on the other, which is x squared. So how many of those do I need? I need 6 of them. So let's fill in that. So Control C, Control V.
How do you know how many to do?
I just have to fill in that space. Right? Do you see why that has to be an x squared? Because it's x on each side. And this one has to be an x squared because it's x on the top and x to the left. And this one has to be an x squared. And then underneath I need 1, 2, 3 more x squareds. So let me do this. Okay. Okay, now I've got to fill in underneath those blue x squareds. What am I going to use to fill in these positions? It's got to be, because notice at the top it's x wide, and on the left it's 1 tall. So that's an x. I need the x that's laying down. So let me do that. Control C, Control V. Okay, so I need 1 there. Control C, Control C, Control V. I need 1 more there. Control C. I need 1 more here. Okay. What about underneath these 1s there?
Oh, up and down.
Yeah, I mean it's 1 wide and it's x tall. That's this one right there. So let's fill in with that. So Control C, Control V. So put the 1 there. I need another right next to it. I need 2 more underneath that. Let me shift. Control C. No, we still haven't filled it all in, right? We got to have it all filled in. What goes right underneath that? Yeah, it looks like 2 1s are going to go there and there. Control C, Control V. Right, so I need 1 there and 1 next to it. Okay, now did we fill in the whole rectangle underneath that? Okay, so now add up everything that we just did. Right, how many x squareds are there? So this is 6x squared. How many x's did we put in there? 7. 1, 2, 3, 4, 5, 6, 7. Right, how many 1s did we use? Plus 2. Done. Okay, and we show one more.
How did you get 7x? So he added 7 of those green. Why didn't you add all of them?
No, these are the ones we started with. We started with these, so these are the ones we're adding up. 1, 2, 3, 4, 5, 6, 7. Right. This is the 2x plus 1, and that's the 3x plus 2. So we did this. 1, 2, 3, 4, 5, 6x squared plus 1, 2, 3, 4, 5, 6, 7x plus 2. Okay. You just multiply. I mean, so when you do this, I mean, you're just going to have to draw your own shapes, right? In some ways, it's probably faster than me fuddling around with PowerPoint, right? But like in this one here, can you just see how many x squareds you're going to have to fill in?
8.
It's going to be 8, right? Because there's 4 on the top and there's 2 on the left. So we're going to have to do this 8 times. So you, like I said, you could do this. You could just draw. Try it. I think it doesn't work if I do it like that. Okay, Control C, Control V. Of course. So I got to put 1, 2, okay, how many, what do I need to do underneath those x squareds?
You need
I need the 1 times x, right? Yeah, probably the 1 laying down, which again, you would just draw it the right way. But I think, okay, there's that. Now what else do I still have to do? I need 2 x's to go here, right?
Yeah, and then 3 1.
Okay. Like I said, if you were drawing it yourself, you'd probably be done by now, but. Okay, and then what's the last thing to fill it all in? I need 3 1s. So I need 1, 2, and 3. Okay, so tell me, what does this equal? 8x squared. See, there's 3 for plus 14x plus 3. Done. Okay, so it's a way to multiply polynomials, binomials, that we will do algebraically next class. But this is supposedly helps some people to see it. Okay, if it does, great. So that's the homework. It's in the book, 4 problems to do that exact same kind of thing. So after the test, work on that. And if you have trouble, then I'm here. I can help you out.